All right, these are the notes for 1.2. We're now going to talk about transformations to linear and absolute value functions. So we will move functions horizontally or vertically. That's just shifting them. And then we'll also reflect them. Okay? So, and we will also have some vertical stretches and shrinks. So if we look at the horizontal translations, the x-axis and the x values is what moves horizontally. So if I'm moving to the left or to the right, I'm changing my x values, okay? So when you have the parent function, which I like to write the parent function of anything, you can just change the parentheses to something else. It's a function where you have some multiplier and you can have absolute value bars or parentheses, but it's x minus h squared plus k. So that's all of it put together. The horizontal translations, we're just dealing with this for both translations. We're just dealing with what's inside with our x. So, I'm sorry, not for both translations, just the horizontal. The vertical translations deals with the k. So we're not dealing with that a out front yet. So if I am moving horizontally, I'm changing my x value. And so if you think of this equation, what is grouped with your x is what moves left and right, because that's where x goes, is left and right. But since it's a minus h, it's always the opposite sign whenever you look at what's grouped with it. So if I do an equation, I'm going to do an absolute value one, where I have an x minus 2. Instead of moving when x goes minus 2 that direction, it actually does the opposite thing, because h itself is just the 2. So it's actually moving positively. So it'll move this way. So horizontal translations, they affect the input. And just make some note, it's the value grouped, it's the number that is grouped with x. So it's going to be inside the function. It's going to be inside parentheses or inside the absolute value bars. And that's what moves us. Okay, so if I just draw my parent function, and I'm going to do my parent function in black here. Okay, it goes through, starts at the origin, and goes through 1, 1, 2, 2, 3, 3, 4, 4. Okay, that's my parent function. And then it's absolute value, so it mirrors. Okay, now if I want to look at this one now, like we said, instead of moving left 2, it's actually going to go right 2. So I just take this whole function and I'm going to shift it right 2. So instead of starting at 0, 0, I'm starting to the right 2, and then I still go up by 1. So it's hard for me to hit those. It's kind of wavy. There you go. Now, if I have 1 and I say, okay, fine, y equals, let's do the absolute value of x plus 3. Well, x goes positive to the right, but h in this case is actually a negative 3 because it's x minus h. So to have that plus in there, it has to be minus a negative. So I'm actually going to move left 3. So instead of starting at the origin at 0, 0, I'm going to move left 3 and put a point. And then I'm still going up by 1 on both sides. Okay, so that's all. When it is grouped with x, that's what happens to the graph. So now if we look at, oops, sorry about that, vertical translations. Okay, so this is a number. It's that k there. Might want to make a note that it is just tacked on to the front or end, so the beginning or end, and it's not grouped with x. It's the constant. It's out there on its own. Okay, and this is what affects the output. So if I plot, again, I'm just using the absolute value, but these work the same for linear, okay? If I draw an absolute value parent function, Make sure it goes through those intersections there. Okay. And then I say, okay, well, let's see if we have the absolute value of x, and now I'm going to go plus 3. Now, this is not grouped with x, so I'm not moving left or right. It's tacked on to the end. So that's really changing my y. So I'm actually going up or down. And in this case, you do exactly what it says. So k in this case is 3, and k makes me go up. Instead of starting at 0, 0, I'm going to start up at 3. And you plot, there you go. So that's what the new graph would look like. And then if I change it and I say, okay, well, how about the absolute value of x minus 2? Okay, that's saying k is a minus 2. So I go, instead of starting at the origin, I go down 2, and I put a point, and I still go with a slope of 1 and mirror it. So there you go. So those are the horizontal and vertical translations. Now, if we look down here, we're going to do a reflection over the x-axis. So in our original function, we had, I'm just writing it down here just to write it. Oops, undo. F of x. And you can write f of x or you can write y. It's not wrong either way. But when we're talking about a function, usually it's f of something. It's just when you're graphing, it doesn't bother me to replace it with a y. Because when you put it in a calculator, the calculator says y, not f of x. Okay, so the function was a times x minus h plus k. Now, if this is absolute value, then you would just make these bars instead of parentheses, okay? Now, this is saying I have a negative in front. So this is my reflection over the x-axis. So this is actually a vertical reflection. All right, so if I draw the parent function, and then I want to draw the function f of x when I have a negative absolute value of x. The only thing that does, instead of having a slope of 1, it's saying my slope is negative 1, so I go down 1 over 1. So it goes down like this. All right. It's changing your, in this case, we'll call it slope because they're straight, but when we get to future functions like quadratics and stuff, I usually call it a multiplier. We will not do reflections over the y-axis, which is a horizontal reflection, but we won't be using those in this section. So that is the first page of the notes. So watch video 2 for the second page.